All right, problem 3-31 says given the parabola f of x equals x squared minus 2x minus 3, complete parts a through c below. Okay, that's weird because there's letter D, but you know, we will still do that one even though the directions tell us just to do a through c. All right, so let's look here. We've got letter A, find the vertex by averaging the x-intercepts. All right, I know a lot of kids in class have been struggling with this, but really, if you just read what it's asking you to do, it's pretty easy. It says find the vertex by averaging the x-intercepts. First of all, let's make sure we remember x-intercepts are where it crosses the x-axis. So the y-coordinate would be 0. Let's take our function here. Let's set it equal to 0 first. So 0 equals x squared minus 2x minus 3. If we're looking to solve this, it's quadratic. So, if you really wanted to take it and use the quadratic formula, you could do that. It's probably going to be just as easy to factor it. I'm going to go ahead and factor this one. This one has no coefficient besides 1 out here for a, so it should be one of those ones that we can pretty much do in our heads. So we've got 0 equals, I know that my first terms have to multiply to give me that first term, so I'm going to have an x here and an x here. Because this is negative 3, I'm going to have different signs. And my factors of 3 are 1 and 3, which means I need to have a negative 3 back here and a positive 1. That way when I add 1x and negative 3x, I get negative 2x in the middle. So let's take it now and let's use our zero product property. So we're going to do x plus 1. Oops, I'm going to turn that into an x. So we have x plus 1 should equal 0, or x minus 3 equals 0. We take it, we subtract 1, we get x equals negative 1. And when we add 3 to each side here, we get x equals 3. These are the x-intercepts. I'll say this is the x-coordinate of x-intercept. We already know what the y-coordinate is. It's 0. So our two x-intercepts are the point negative 1, 0 and the point 3, 0. Now, we're going to average the x-coordinates of the x-intercepts to find the axis of symmetry. So we have negative 1 and 3. If I say x equals, remember this would give me a vertical line. I'm going to say negative 1 plus 3, and I'm going to divide it by 2 because I'm taking the average of the two. Negative 1 plus 3 is 2. We have 2 over 2, which is 1. So the equation for the axis of symmetry I'm going to abbreviate it AOS. Is x equals 1. So if we were to just kind of look at it here as we've got to sketch out our parabola here. Let's say if we were, this is our y-axis, this was our x-axis here. And I'm going to change colors, maybe. All right, so we would know that we had an x-intercept here at negative 1. That's at negative 1. And we had an x-intercept at 0, 1, 2, 3. Let's say we have 3 right here. Our axis of symmetry is the equation x equals 1. So at 1, we've got this imaginary line. We dash it just so we know it's not actually points on the graph. And our vertex lies on this line. So we know that the x-coordinate of vertex is 1. So if we're trying to come up with our vertex, we're going to say our vertex right now is 1, comma, something we don't know. But we do know that if we take this 1 and we plug it into our function, we should be able to get the output. So we're going to do f of 1, or the function f of 1, equals 1 squared minus 2 times 1 minus 3. 1 squared is 1, negative 2 times 1 is negative 2, and then we have minus 3. So we're going to have negative 1 minus 3, which gives us negative 4. So f of 1 equals negative 4. That means our vertex is the point negative 1, I'm sorry, positive 1, negative 4, which means it'd probably be somewhere right down here at negative 4. And see, it would go up like this and like that. All right, so we found the vertex there by averaging the x-intercepts. Now what we're going to do here is we're going to go ahead and find it by completing the square. So I'm going to take it here, I'm going to switch colors, and let's see, we'll probably squeeze that in right in here. Let's go right here. We've got B. We're going to find the vertex by completing the square. So right now we've got f of x equals x squared minus 2x minus 3. I know a lot of you have been using the generic rectangle to help complete the square, so we'll go ahead and do that right now. Here's our generic rectangle. Remember, we're not actually just factoring it this way, we're using it to help us complete the square. We want it to be a perfect square trinomial, so we're going to have to change that number right there. So let's put the other numbers in that we know. We take our x squared, the first term, and we put it down here. We're going to split this one in half. So if we have a negative 2x, that came from adding this box and this box, which means we're going to have to put a negative 1x here and a negative 1x there. Okay, our negative 3, I'm just going to leave it outside here. We don't, we need to change this number, so this is what we have. This will tell us what we need. So if I put an x here, x times x gives me x squared, times negative 1 gives me negative x, x times negative 1 gives me negative x, and then negative 1 times negative 1 gives me positive 1. So what do I have to do to negative 3 to get positive 1? Well, I'm going to have to add 4. I have to add 4 to that. If I add 4 to it, I get negative 3 plus 4 gives me 1. So I'm going to add 4 here, and I'm going to add 4 on this side. So what we now have is f of x plus 4 equals x squared minus 2x plus 1. And you notice that's exactly what we have in the box here. And that's our area as a sum. If we look at our area as a product, it's x minus 1 times x minus 1. So let's go ahead here and let's rewrite this as the quantity of x minus 1 times the quantity of x minus 1. Right now we've not changed the left side, so we have f of x plus 4. This can be rewritten as x minus 1 squared, or that whole quantity squared. And now that still is equal to f of x plus 4. And to get it all the way to our vertex form, remember we have to subtract 4 from each side. And we get f of x equals the quantity of x minus 1 squared minus 4. And now when we look at it here, remember we want to come out with our value of hk. So we're going to look at, this is like saying x minus positive 1, so h here has to be positive 1. which correlates to what we had when we solved it over here, 1, -4. And notice our k value is -4. So we've solved this for the vertex, 2 different methods, but we got the same answer. Now letter C says find the vertex of f of x equals x squared plus 5x plus 2 using your method of choice. So you can use whichever method you want to use here. I'm going to use completing the square. Let's switch my color here. So letter C, should make it a little thinner too. We have there f of x equals x squared plus 5x plus 2. Let me fix that. Sorry about that. All right, so let's take it here. I'm going to complete the square. So I'm going to take it and look at, for those of you like the generic rectangle, I'll do that again. Eventually we're going to wean you off of this and have you do it a different way. So we've got x squared. Put that one down here. I've got my 2 just left over, chilling up here. We got 5x. We're going to take that, split it in half. So we've got a positive 2.5x here and a positive 2.5x here, which means on the outside we have x plus 2.5 and x plus 2.5. And when we do 2.5 times 2.5, we're going to end up with 6.25. And that simply means then that we are going to have to add 4.25 to our 2 to get 6.25. So we're going to add 4.25. We're going to add it over here also. And don't be afraid to show your work and show each step here. The people who keep missing this problem or these kinds of problems are the people who want to rush through and skip steps. If you just treat it like it's an equation, you keep it balanced, you won't have any problems. So don't be lazy. So we have f of x plus 4.25 equals x squared plus 5x plus 6.25. The whole reason we changed 2 to 6.25 is so that we could factor this into x plus 2.5 times x plus 2.5. I'm just going to bring down what I have. Let's rewrite this as x plus 2.5 squared and we have f of x plus 4.25. Remember, your last step is to get k over here, so we subtract 4.25 from each side, and you've made it to your vertex form. So f of x equals x plus 2.5 squared minus 4.25. So our vertex ends up being negative 2.5. Remember, it's the opposite of what we're seeing in here, and negative 4.25. That is our vertex. That is part C. Now we will still sneak in that other part D that it asks for the domain and range of the parabola that we just found the vertex of. Well, we know every parabola should, if it's just graphed on there as a function, the domain is going to be all real numbers. You can write it as the fancies are. You could do negative infinity to positive infinity in parentheses. Our range, since this one opens up, our lowest point, our minimum, is going to be at negative 4.25. So you could either say that y is greater than or equal to negative 4.25, or Could use interval notation here. Oops, I jumped the gun a little bit there. We could say here bracket negative 4.25 because we're including that point, and it goes to positive infinity, and we put a parenthesis there. So there's our domain and there's our range written in a couple different ways so you can check your work. This is problem 3-31. If you still have questions about this, you need to make sure you're getting them answered. We've been doing this for a while now. If you have questions, see your teacher or go to Math Help. Thanks for watching.